RS485 is older than most of the engineers wiring it today. The standard was published in 1983, and yet it is still the default connection on drives, power meters, temperature controllers, and sensors across the whole industrial world. Newer, faster networks have come and gone. RS485 just keeps showing up. So why does an ancient serial standard refuse to die? In this video, I will explain what RS485 actually is, starting from plain serial and the problem it solves. Then I will show why differential signaling makes it almost immune to factory noise, how dozens of devices share just 2 wires, and how Modbus rides on top of it. Let's start with the wire. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC networking and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the serial line. Start with serial. Serial just means sending data 1 bit at a time down a wire, instead of many bits side by side. The classic serial standard is RS232, the old 9-pin port. And RS232 has a built-in weakness. It is single-ended. Every signal is measured against one shared ground wire. The receiver looks at the voltage on the signal line and compares it to that ground. That sounds reasonable until the cable gets long. Any noise the cable picks up from a nearby motor, a contactor, a drive, rides straight onto the signal, and it gets read as real data. So RS232 is stuck with short runs, slow speeds, and just one device on each end. On a quiet desk, fine. On a factory floor, it falls apart. Here is how RS485 fixes it. Differential signaling. Instead of one signal wire against ground, RS485 uses 2 wires, usually called A and B, twisted together as a pair. The receiver does not read either wire against ground. It reads the voltage difference between A and B, and that is the whole trick. When a cable picks up noise, that noise lands on both wires almost equally, but the difference between them barely changes. So the noise cancels itself out. The proper name is common mode rejection. It is why RS485 stays clean, where RS232 would be garbage, and why a single link can run reliably up to about 1,200 meters. Same idea, completely different result. There is a second reason RS485 wins. It is a multidrop bus. RS232 is point-to-point. One device talks to one other device. RS485 lets many devices share the very same A and B pair. You wire them in a daisy chain, node to node, down a single twisted pair, and every device listens on the same line. One master can pull 32 devices, or more with the right drivers, over 2 wires and a ground. Think of a row of power meters down a panel, or a string of drives along a machine. Instead of a separate cable to each one, they hang off one bus. Less wire, less conduit, less to troubleshoot. That alone sells it on big installations. Now an important distinction. RS485 by itself does not say anything about the data. It only defines the physical layer, the wires, the voltage levels, the differential signaling. It does not decide who talks when or what the bytes mean. That job belongs to a protocol on top. And the protocol you will meet most often is Modbus RTU. Modbus RTU defines the addressing, the function codes, and the simple master asks, slave answers traffic rules. RS485 plus Modbus is one of the most common pairings in all of industry. I have a separate video comparing Modbus to Profibus, Profinet, and the industrial Ethernet world. It is linked below. Finally, the wiring you will actually do and the classic mistakes. First, polarity. A goes to A, B goes to B, the same way down the entire chain. Swap them on one node, and that node simply will not talk. Second, termination. On a long bus, add a resistor across A and B at each far end, usually 120 ohms. It stops signal reflections. Third, bias. Set bias resistors so the idle line rests in a known, defined state instead of floating. Fourth, ground. Tie a common ground reference between nodes so the receivers share a baseline. Skip termination on a long run, forget the bias, or reverse the polarity, and you get intermittent comms faults. The kind that work on the bench and fail in the panel. So here's what to walk away with. RS485 is a differential serial standard. And that one idea, reading A against B instead of against ground, is why it shrugs off factory noise. It runs to 1200 meters. It is a multidrop bus, so many devices share 2 wires. And it is just the physical layer, Modbus RTU, usually rides on top. Get that, and every serial device on the floor stops being a mystery. Now, go make it concrete. If you want to practice PLC networking hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.